Welcome back everyone, and in today's video we are going to solve another problem from trigonometry. The question that we are going to solve today is state whether the following are true or false. Justify your answer. Number 1, the value of tan A is always less than 1. Number 2, sec A is equal to 12 by 5 for some value of angle A. Number 3, cos A is the abbreviation used for the cosecant of angle A. Number 4, cot A is the product of cot and A. Number 5, sin theta is equal to 4 by 3 for some angle theta. Okay, so let's try to first solve question number 1. And in this question number 1, it says that the value of tan A is always less than 1. So we need to prove that whether this statement is true or false. So let us suppose that the angle A is equal to 60 degree. Let's see what will happen to tan A if A is equal to 60 degree. Now if A is equal to 60 degree, then tan A is equal to tan 60 degree, and tan 60 degree is equal to sin 60 degree divided by cos 60 degree, as tan theta is equal to sin theta by cos theta. And sin 60 degree, that will give you root 3 by 2. Cos 60 degree, that will give you 1 by 2. 2 into 1 can be cancelled out, and you will only remain with root 3. The approximate value of this root 3 is equal to 1.732, which is clearly greater than 1. Hence, we can conclude that for some angle A is equal to 60 degree, tan A is not always less than 1, but is greater than 1, which breaks this given statement. Thus, we can say that the given statement is false. Hence, the given statement is false. So that's the answer. Okay, so let's move on to the second question. If you look at the second question, it says that sec A is equal to 12 by 5 for some angle A. And we need to prove that either this statement is true or false. Now, the trigonometric ratio of sec A, is equal to hypotenuse by base. And if you compare this trigonometric ratio of sec A with this given one of sec A, then we can say that hypotenuse H is equal to 12. Base B is equal to 5. And for this problem, let us consider a right-angled triangle ABC. Let us consider a right-angled triangle ABC, where A is here, B is this point, and C is this point. So sec A, that is AC is like the hypotenuse, so it is 12, and AB is like the base, so that is 5. So if you look carefully here, that BC acts like the perpendicular of a right-angled triangle. In order to show that this statement is true, we need to show that there exists a perpendicular BC such that that perpendicular is always less than the hypotenuse, and if you add that perpendicular with any other two sides, it will be always greater than the third side. So let's do this by applying the Pythagoras theorem. So by Pythagoras theorem, if you apply, AC acts like the base, AC acts like the hypotenuse, AB acts as the base, and BC acts as the perpendicular. So by Pythagoras theorem, BC is equal to root over AC square minus AB square. AC, if you substitute the value of AC, is equal to 12, and here the hypotenuse, I think we can also write as AC in place of H, and in place of base I can write as AB. The value of AC is 12, so 12 square minus 5 square. 12 square, that will give you 144, minus 5 square, that will give you 25. 144 minus 25, then BC will give you root 119. And the approximate value of root over 119 is 10.9. And clearly 10.9 is less than 12. And if you add this 10.9, this BC 10.9 with either of the two sides, it will be always greater than the third side. 10.9 plus 5 is greater than 12. 10.9 plus 12 is greater than 10.9 plus 12 is greater than 5, and 5 plus 12 is greater than 10.9. Hence, we can conclude that such a right-angled triangle exists. Thus, the given statement is true. Thus, the given statement is true. Now, let's move on to question number 3. And if you look at question number 3, it says that cos A is the abbreviation used for cosecant of angle A. Then here clearly you can say that cos A is not the abbreviation used for cosecant of angle A, whereas cos A is nothing but the cosine of the angle A. Hence, we can say that the given statement is false. If you look at question number 4, it says that cot A is the product of cot and angle A, and this statement is clearly false since cot A is the cotangent of angle A, and it is not the product of cot and angle A. Now, the last question that we are going to do here is question number 5. If you look at question number 5, it says that sine theta is equal to 4 by 3 for some angle theta. We need to prove that whether this given statement is either true or false. Now, we all know that the trigonometric ratio of sine theta is equal to perpendicular by hypotenuse. Perpendicular by hypotenuse. If you compare the trigonometric ratio of sine theta and the given value of sine theta, we can conclude from these two equations that perpendicular is equal to 4 and hypotenuse is equal to 3. And if you look from these two values, the values of perpendicular is 4 and the value of hypotenuse is 3, which is not possible because we all know that the hypotenuse must be the longest side of a right-angled triangle. So therefore, we can conclude that this given statement is false since the hypotenuse is less than the perpendicular. So we can write since hypotenuse is less than the perpendicular, therefore given statement is false. I hope you've learned a lot from this video, and if you have any questions, any doubt, please feel free to drop it in the comment below because your feedback is important to us. Stay safe, God bless you, don't forget to subscribe.